transit. Okay, last time I saw you guys, we were talking about what makes functions relations a function. We were talking about domain and range, inputs and outputs. Okay, we're talking about all of those things, and we were talking about them from maps, we were talking about them from tables, from ordered pairs, and from graphs. Okay, so we're going to run through, I don't know, 5 or so examples. Okay, we're going to talk about domain and range. We're going to talk about all those things I just mentioned to make sure that we're good with all those vocabulary words. Okay, so our first question is going to be determining which of these relations that are listed here are functions. Okay, so there's only one. And remember, for a relation to be a function, none of the inputs can repeat. None of the inputs can have 2 different outputs. Okay, so remember, input is X, output is Y. So looking at our first set of ordered pairs, my inputs are what cannot repeat. So my inputs here are -6, 3, 10, and 3. This first guy can't be a function because that 3 repeats. The 2 x's are the same with 2 different y's. So 10 is not a function. Or I'm sorry, A is not a function. For B, I've got -2, 5, 16, and -3 as my set of inputs. None of those numbers repeat. So B is definitely a function. Looking at C, just to be sure that we're correct, we've got 5, -3, -3, and 4 as our x coordinates. Since 2 of them are the same, not going to be a function. And letter D, we've got 21, 21, 21, and 21. Guess what? All of those numbers are the same, and they all have different outputs. So D is not going to be a function either. Okay, so remember, no repeating x's, no repeating inputs. Okay. Talking about domain and range, let's find the domain and range for the one that was a function. So domain, remember, is listing out all of the inputs. Range is listing out all of the outputs. So my domain for letter B is all of my x coordinates listed out. So we've got -2, 5, 16, and -3. Those 4 are my 4 x coordinates for those ordered pairs. My range for this function is all the y coordinates. So I've got -1, -1, 3, and -9. So my range is all those numbers listed out. Okay. So that's ordered pairs, which brings us to tables. So remember, X is input, Y is output. We want to find the table where none of the X's are the same. A is not going to be a function because 2 of the X's are the same. B is not going to be a function because 2 of the X's are the same. C, all the X's are different. They have the same output, but that's okay. Outputs can repeat, inputs can't. So C is going to be a function. And just to verify, D won't be a function because all the X's are 1, which means they're all the same, which means it can't be a function. Okay, so C is our only one that is a function. And just for time's sake, I'm not going to go over domain and range for a table, but our domain would just be the X's and our range would just be the Y's, just like above. A little easier on a table though, because they're already organized for you. Brings us to our mappings over here, guys. We want to figure out which one is not a function. So we want to find the one of these that is not a function. Well, 1 has 1 output, 1 arrow. 2 has 1 output, 1 arrow. So A is a function. Letter B, 1 is mapped to 1, 2 is mapped to 2. Neither of the inputs where the arrows start have more than 1 arrow. So B is a function. Letter C, 1 goes to 1, 2 goes to 1. Neither of the 2 inputs have 2 or more arrows, so C is a function as well. Looking at D, I only have 1 number in my input, but I have 2 outputs, and there's 2 arrows coming from 1. Since 1 has 2 outputs, D is not a function. So for this one, our domain and range, okay, our domain and range right here, our domain is the set of inputs. There's only 1 input here. It's just 1. Hold on 1 second. Okay, so our domain is just 1. We only have 1 input here. Our outputs are our range. So our outputs here are 1 and 2. Okay, which brings us to number 4, guys. We have 4 graphs. And if you remember, when we're determining if a graph is a function, we use the vertical line test. Only one of these 4 lines passes the vertical line test. So we've seen a circle before. We know circles don't pass the vertical line test, because there's lots and lots of places on the circle where the line would pass through 2 points. Square is kind of like a circle, but pixelated, right? So if I draw a vertical line on a square, it passes through 2 points. Okay, so B and D, not functions. Does not pass the vertical line test. Looking at C is a vertical line. So if I were to draw a vertical line on that vertical line, look how many points we hit. We hit points everywhere on that line. Since we hit more than one, all we need to hit is 2 for it to not be a function. So C won't be a function either. Brings us to A. This one should be a function since these 3 weren't. So if I draw vertical lines across this entire line, there's not a single place where I'm going to hit more than 1 point. All those lines hit 1 point each. So A is a function. Okay, we're not going to go over domain and range for graphs just yet, but we do know the vertical line test, so we can determine if they're functions or not. And last but not least, we've got 3 different functions here. We know these are functions because they pass the vertical line test. We want to determine which function matches these data points. So we have ordered pairs 0, 0, 1, 3. Might help to write them as ordered pairs because that's how we're used to seeing ordered pairs. Okay, and we want to find which graph has all of these points on it, because if it doesn't have all these points, it doesn't match the data in the table. So 0, 0. All of the graphs in A and B have 0, 0. C doesn't. That would be right here. So we know C doesn't match the table. We got 1, 3. Okay, 1, 3 means over 1, up 3. This guy right here doesn't quite look like 1. It looks like about 2 or 3. Okay, so we know A doesn't have this point on it. I'm sorry, this point on it, 1, 3. Just to verify, we got 2, 6. That one's there. 3, 9. Boom, boom. And 4, 12. So we know B has to be the graph that matches the table, the ordered pairs in the table. Okay, so that's pretty much everything we talked about last week. We talked about domain and range. We talked about ordered pairs, tables, mappings. We talked about the vertical line test. We saw the vertical line test. Okay, so that's our review from last week.